Welcome to the Society of Amateur Radio Astronomers. Radio Astronomy, Constant Variables and Formulas. Lesson 10, Distance Math. Astronomical units, parallax, parsecs, and light years. An astronomical unit in light years. The AU, astronomical unit, is the mean distance from the Earth to the Sun. It's been measured as 1.5 times 10 to the 8th kilometers. A light year is the distance traveled by the speed of light in 1 year. So 1 Earth year is equal to 365 days times 24 hours per day times 60 minutes per hour times 60 seconds per minute. It's equal to 31,536,000 seconds. Since the speed of light is 3.0 times 10 to the 5th kilometers per second, 1 light year in kilometers is equal to the speed of light, 3 times 10 to the 5th kilometers per second, times 31,536,000 seconds. It's equal to 9.47 times 10 to the 12th kilometers. 1 light year in astronomical units is equal to 9.47 times 10 to the 12th kilometers times the conversion factor of 1 astronomical unit for every 1.5 times 10 to the 8th kilometers is equal to 6.31 times 10 to the 4th astronomical units. What is a parsec? 1 parsec is defined as the distance in which the radius of the Earth's orbit subtends an angle measuring 1 arcsecond. So if you look at the Earth's orbit radius of 1 astronomical unit, and you make a right triangle out of that, the parallax angle from the Earth, if that equals 1 arcsecond, then the distance r is equal to 1 parsec. So we'll define that r is the distance and theta is the parallax angle, which will make 1 arcsecond. When we use radians, that the arc length is equal to r theta. So therefore, r theta is equal to the Earth's orbital radius is equal to 1 AU. Now to figure out the theta in radians, 1 arcsecond times 1 degree over 3,600 seconds times pi radians divided by 180 degrees. It's equal to 4.85 times 10 to the minus 6 radians. Now, it's thing to note here is that radians is a dimensionless unit. I'm keeping the radians just to keep track of what numbers are radians and which are not. Now, r at 1 parsec is equal to 1 AU over theta. So it's 1 AU divided by 4.85 times 10 to the minus 6 radians is equal to 2.06 times 10 to the 5th astronomical units. 1 parsec in light years is you take the 2.06 times 10 to the 5th AU and you put a conversion factor of 1 light year over 6.31 times 10 to the 4th AU. So 1 parsec is equal to 3.269 light years. Let's do an example. Proxima Centauri, the parallax angle to Proxima Centauri is 0.77 arcseconds. What is the distance in AU, parsecs, and light years? So the parallax angle of 0.77 arcseconds, first you need to convert that to radians. So you take the 0.77 arcseconds times 1 degree over 3,600 seconds times pi radians over 180 degrees is equal to 3.73 times 10 to the minus 6 radians. So now R is equal to 1 AU over theta in radians. That's equal to 1 AU over 3.73 times 10 to the minus 6 radians is equal to 2.679 times 10 to the 5th AU. So that's the distance in AU to Proxima Centauri. In parsecs, we'll take that same AU number, 2.679 times 10 to the 5th AU, and we'll apply the conversion factor of 1 parsec over 2.06 times 10 to the 5th AU. Therefore, it's equal to 1.3 parsecs. In light years, we'll take the AU number again, 2.679 times 10 to the 5th AU, and multiply times the conversion factor of 1 light year over 6.31 times 10 to the 4th AU is equal to 4.24 light years. Let's do example 2, Betelgeuse. It's 497.95 light years from Earth. So what is the expected parallax angle in arc seconds? If you take the distance and convert it to AU, 497.95 light years, and you apply the conversion factor of 6.31 times 10 to the 4th AU per 1 light year, therefore it equals 31,420,645 AU. And if you take the theta, remember theta times R in AU is equal to radians. So theta in radians is equal to 1 AU over 31,420,645 AU is therefore equal to 3.18 times 10 to the minus 8 radians. To convert that radian value to arc seconds, we take the 3.18 times 10 to the minus 8 radians and multiply it by 1 arc second over 4.85 times 10 to the minus 6 radians. And that gives us 0.0066 arc seconds parallax angle for Betelgeuse. If you like this video, like and subscribe. Join SARA to start your hobby of amateur radio astronomy. Go to our website, www.radio-astronomy.org. Thank you.